All right, guys, I'm going to look at a question today from a student sent in a question from study guide or homework or whatever. Uh, Find an equation of the normal line of a function, this function that they give you at x equals 3. So a couple things we need to know, right? What's a normal line, first of all? Second of all, what kind of function are we talking about? How do we find the normal line then? Okay, so normal in this case doesn't mean ordinary. Normal in this case means means perpendicular. Comes from a Latin word normalis, which usually meant a carpenter's square. Normal, normalis, carpenter's square. Carpenter's squares are. I'll show you one. I'll show you one here, or I don't know. I'll put it up on the screen somewhere. So how do we find a normal line of a function? Well, first I need to find a tangent line of that function. Tangent line means I get to use calculus. All right. So if you already know how to do derivatives, this is going to be super easy for you. If not, I'll show you a really quick way to do the derivative, to take the derivative. Derivative just means slope of the line, slope of the function at any part of the function. So in this case, look what kind of function we've got. We've got a cubic, which looks like this. I've gone ahead and marked where x equals 3, the function value, the y value is negative 3. You can see that right there. So what we're looking for is we got to find a normal line which is going to be perpendicular to the function just at that one exact point of the function. So in order to do that, I got to find a tangent line first. Tangent line is going to be the derivative is going to be the slope of that tangent line. So I got to find that slope. I got to find that derivative. So I just use the power rule here. I take the exponent of the first term, that goes down in front and multiplies by the current coefficient, which is 1. So I get 3, and then the exponent on the x is going to go down by 1. So the derivative of x cubed is 3x squared. And then likewise, the derivative of negative 4x squared, I take that square and multiply it by 4, and I get negative 8x. The exponent goes down by 1, so x to the first. And then on this one, it's just x, so the derivative of that is just 1, because it's x to the first power. That first power multiplies with the current coefficient of 1. 1 times 1 is 1. X goes to x to the power of 0, so that's just 1 also. The derivative of any constant is 0. So that does not get included. Now, this is going to be the function of the slope of the original function at any given value. So when I overlay these, check this out. The slope of the red function here, the slope of the cubic function at any given point is the value of my quadratic, my parabola. So that we'll get more into that when we look more at calculus, look more at stuff like that. But so now I've got the slope at any given point on the original function, but I want the slope at just that one point. So what I'm going to do there is just plug in my x value. So I'm going to do that right now. F prime of 3. So then when I calculate this, simplify it all, I get a slope of 4. So my slope is 4 there, which means my tangent line I can write in point slope form, because I know that the point is 3 comma negative 3. So I know that I can put that in point slope. Y minus the y value, so plus 3. Y minus negative 3 is plus 3. Equals my slope 4 times x minus 3. X minus the x value of my point. So now when I type that in, I can see that that is my tangent line at that point. If you got really close in there, you can see that it touches that point and keeps moving in a straight line instead of along the curve. So that's the tangent line at that point. But I want what? The normal line. I want the perpendicular line. So remember, what we know about perpendicular lines, their slopes are opposite and reciprocal. So the slope of this line at this point is 4. So the slope of the normal line, I'll say m sub n for normal. M sub n, the slope of the normal line is going to be negative because this slope is positive. So it's going to be negative. The reciprocal of 4 is 1/4. So then I can just plug that also into point slope form and get y plus 3 is equal to negative 1/4 of x minus 3. And then if you wanted to change that to slope intercept, you can just by distributing that negative 1/4 and subtracting 3 from both sides. And I'll put what do we get here. Those are equivalent equations of the normal line to that function, that cubic function at that point, 3 comma negative 3. You can see here, just at that one point, that line is perpendicular or normal to the function. All right, guys, hopefully that was helpful. If you need any other further assistance, if you need one-on-one help, if you have questions you want to send in and have me cover on the channel, send them either in below or send them an email. I'll put all the links below. And until next time, thanks.